Okay, so what will happen here? A 1,2-dicarbonyl compounds. And this kind of molecules are also called as alpha diketones. Alpha diketones, when it is treated with carboxylic acid, it undergoes rearrangement. Rearrangement involve 1,2 shift of phenyl group and giving rise to a alpha hydroxycarboxylic acid. This kind of rearrangement is called benzylic acid rearrangement. So if you are looking into the mechanism, the anion, okay, means anion means hydroxyl anion. So this will attack the electron deficient carbon, and the bonded pair will go and sit on the oxygen as a anion. That's what I have mentioned here. So in this case, so there will be involvement of 6-electron system. That means this anion can come over here, this bond pair can go over here, and this bond pair will sit on the oxygen. So, and this shift is called 1,2 shift. 1,2 shift means there will be a movement of phenyl group from this carbon atom to this carbon. Okay, so the obtained one is this, and this, for this what will happen, there will be a proton transfer. Proton transfer means movement of this carboxylic acid proton moved from carboxylate to uh, phenoxide anion. So then after at the end, it's a what is called as taking the proton when it is treated with acid. This is about the mechanism and the what is called reaction. So the what you can get a questions maybe in the main examination. Write a note on benzylic acid rearrangement, and it is asked 3 marks question in 2003. So then you have to explain all these things. First, you can write the mechanism. You can also explain about the rearrangement. How so these kind of moieties are called diketones. The diketone catalyzed a strong base. So here the strong base means KOH. So what will happen? There will be a involvement of migration of phenyl group from first position to second position, giving rise to alpha hydroxy carboxylic acid. This reaction is called benzylic acid rearrangement, and the mechanism also you can write. And so with this, we'll go to the next slide. Next slide will give you the information about the little more information. So what I explained in terms of mechanism, that itself here it's written as in words. So mechanism starts with the addition of nucleophile to benzoyl. This is called Benzoyl, benzoyl carbon. So that's what you can write here. So okay, I will write. I can write overall here Benzoyl, benzoyl carbon. So that means nucleophile attacks to the benzoyl carbon, which is fast and reversible reaction. And the second step is slow and the rate determining step. Okay, and where the phenyl group adjacent to the carbon, which is intramolecular rearrangement, followed by the shift of resonance stabilized by carboxylate anion. So what is the mechanism is there? That mechanism here written in terms of words. That's all. So then if we are looking into the application, the benzylic acid rearrangement is particularly useful for the synthesis of uh, citric acid. Citric acid means this is the one, citric acid. So citric acid means it contains 3-carboxylic acid. In addition to 3-carboxylic acid, it also having one hydroxy group. I think you know that citric acid, it is present in almost all what you call citrus fruits. Okay, that means how this can be, citric acid can be synthesized in a laboratory. It is starting with the ketopinic acid. So ketopinic acid is this one. So of course, if this generally we can call it as a alpha diketones. This alpha diketones, when it is treated with a base, the base may be sodium hydroxide or potassium hydroxide. So what will happen? Again, this anion will attack here. So there will be a movement of this phenyl group, this CH2COOH group to this carbon, and this CO is gets converted into OH, and this CO is gets converted into carboxylic acid. That's what the product I have written. You can also try the mechanism for writing for the conversion of ketopinic acid to citric acid. That also you can do it. So this is about the benzylic acid. Then up to this, what and all we learned? We learned about the Wagner Meer rearrangement. We learned about the allylic rearrangement. We learned about the pinnacle rearrangement. We learned about the Hoffman rearrangement. We learned about the Beckmann rearrangement. We learned about the Baeyer-Villiger oxidation. We learned also about benzylic acid. So these are the 7 rearrangement under the chapter name called rearrangement. So what will happen here? There will be a migration, more particularly 1,2 migration. Migration may be a alkyl group or methyl group or phenyl group. Overall, there will be a migration towards the carbon, electron deficient carbon, electron deficient oxygen, electron deficient nitrogen. So that's what we discussed under this chapter. So what I will do with this I will discuss about the what are the questions you can expect from this rearrangement in your main examination. That I will discuss now. So that means few questions on rearrangement. So give an allylic rearrangement reaction. Here what you need to do, you need to write only the reaction, not the mechanism. Only you have to write the reaction. Maybe you can take what is called as 3-chlorobutene. So that example you can take 3-chlorobutene when it is treated with ethanol. So more particularly it's called solvolysis. Solvolysis means solvent is reacting with the substrate. So solvolysis of 3-chlorobutene. So that you can take and write the product. That's what you can do it. So since it is asked for only the 2 marks. And one more thing, allylic usually it will ask for the 2 marks only, not for the 3 marks and higher marks. So then that's what you can do. Anyway, then if you are looking at the molecular rearrangement in organic reaction, that means molecular rearrangement, all this rearrangement, whatever I mentioned, Wagner, Pinnacle, Beckmann, Bayer, okay, Hoffman, okay, all these reactions are molecular rearrangement itself. But you can take any one, two, you can take it and you can write the example reactions that you. It's a general question. You can take any rearrangement and explain it for 3 marks question. And write a note on benzylic acid rearrangement. Just now we discussed about the benzylic acid rearrangement. So what will happen here? So there will be a conversion of alpha diketone, alpha diketone when it is treated with strong base called potassium hydroxide undergoes benzylic rearrangement giving rise to alpha hydroxy carboxylic acid. So it's called benzylic acid, but you have to write the reaction and also you need to write the mechanism. If possible, you also write the application, that is called ketopinic acid conversion to citric acid. That's also you can mention. So in other way, same question how one can ask, how do you convert alpha diketone to alpha hydroxy carboxylic acid? In other way, you can also expect this question. What is that question? How do you convert alpha diketone to alpha hydroxy carboxylic acid? That is nothing but a benzylic acid rearrangement. So benzylic acid rearrangement or benzylic acid rearrangement, both are same, that you need to remember. Then give the mechanism of Beckmann rearrangement. So Beckmann means it is the reaction used to convert a oxime, okay, used to convert a oxime into substituted amide. So these reactions are catalyzed by acids such as thionyl chloride, phosphorus oxychloride, phosphorus pentachloride. So one more question also asked based on the Beckmann rearrangement. So how do you convert an oxime into a amide? So oxime into amide is nothing but a Beckmann rearrangement that you need to remember. So in this question, what you can do, you can write the oxime and how the oxime is the reactant, H plus is the reagent, and product is the amide, substituted amide you need to write. And you can also write the general mechanism or the specific mechanism for this reaction. So then what you can do, you can go for the next question. So give the mechanism of Bayer-Villiger reaction. Bayer-Villiger reaction or Bayer-Villiger oxidation, both are same. So what will happen here? A ketone is converted into ester. So one can frame the question in such a way that how do you convert a ketone into ester? So that is also a one can frame a question on Bayer-Villiger oxidation. So that means in the Bayer-Villiger oxidation, a ketone is treated with per acid. Per acid means one oxygen is added to the carboxylic acid. Such compounds are called per acids. So per acid's role is addition of oxygen. So addition of oxygen is, you know that it's a oxidation process. Then what will happen? Addition of oxygen to the ketone, you will get a ester. So that's all. That's about the reaction, and you need to write the mechanism. How the per acid will attack the protonated ketone, and then afterwards the intermediate obtained one is how it will undergo rearrangement, and how the byproduct carboxylate is released. Those things you need to write it in this Bayer-Villiger oxidation. But you need to remember that Bayer-Villiger oxidation is nothing but a conversion of ketone into ester. That's what you need to remember. And if there is a reagent called peracid, that is nothing but a Bayer-Villiger oxidation only. So then write a short note on pinnacle pinnacolone. Pinnacle pinnacolone rearrangement. So pinnacle means dihydroxy adjacent vicinal diols. So vicinal diols are called pinnacle. So vicinal diol where in presence of acid gets converted into pinnacolone with the involvement of migration of 1,2 shift of methyl group or phenyl group. So this type of reactions are called pinnacle pinnacolone rearrangement. So you need to write the reaction first, and then you have to write the mechanism. Similar kind of pinnacle pinnacolone rearrangement is amino bromide, amino alcohols. So also undergoes pinnacle pinnacolone kind of rearrangement. So here what is the driving force? The driving force for this reaction is the movement of after the moving of migration 1,2 shift of the alkyl or aryl group, so end up with the tertiary carbonyl. So tertiary carbonyl is more stable. That is the driving force for this rearrangement. So then Beckmann. So I'm already discussed about the Beckmann, but here write a note. Write a note or give the mechanism of Beckmann. Whatever, if there is a Beckmann, you write the same thing, reaction, mechanism, and then example. So you can observe that Beckmann is asked in the 2008. It's also asked in 2003. It's also asked in 2011. It's also asked in 2013. Overall, so here you can get the direct questions. Sometimes indirect questions also you will get, but you should be familiar with that. So if indirect question can be framed on Beckmann rearrangement, that is called how do you convert a oxime to ester. So that is oxime to substituted amide is the indirect question one can ask on the Beckmann rearrangement. Then I will go to the next question. So here also Beckmann rearrangement. So oxime is converted into substituted amide. Hoffman rearrangement. Hoffman rearrangement means it's a conversion of amide to amine with the loss of one carbon atom. So that is important. So the Hoffman rearrangement means the conversion of amide to amine with the loss of one carbon atom. is called Hoffman rearrangement. And here the Hoffman reagent is the sodium hypobromide. Sodium hypobromide, how you will get? By the just the combination of sodium hydroxide and bromine, you will get a sodium hypobromide. So the sodium hypobromide is very unstable, and it is stable at 0 to 5 degree temperature. So then here what you need to do, you need to write the reaction first. Write the amide, treat with the sodium hydroxide in bromine, and gives rise to amine with the liberation of carbon dioxide. That's what you can write, and you need to write the mechanism. So mechanism means in the first step there will be a formation of sodium hypobromide by the reaction of sodium hydroxide and then bromine. And the next step is the reaction of hypobromide with the amide, forming N-bromo compound. N-bromo compound, when it is treated with the sodium hydroxide, there will be a formation of anion and the nitrogen. Then there will be a 6-electron rearrangement, 6-electron involving rearrangement. There will be a movement of alkyl or aryl group from the carbon to the nitrogen. This is an example of migration of alkyl or aryl group to the nitrogen, electron deficient nitrogen. So that means you can write the mechanism and you can also give the example. So that is enough for the 4 marks question. So then describe the mechanism of pinacol and Baeyer-Villiger rearrangement. So this question is asked in 2005 and 2003. So you know that pinacol. You also know about Baeyer-Villiger. So pinacol means vicinal diol converted into ketone. Baeyer-Villiger means a ketone is converted into ester. So similarly, discuss the mechanism of Wagner-Meer rearrangement. You can remember that this Wagner-Meer rearrangement, it is asked for the 5 marks question, and it is asked in 2009, it is asked in 2016, it's also asked in 2015. So this is the first rearrangement. So that is the reason you can have a high on this. So there may be a chance. Okay, and then so again, how one can change the question by taking a suitable example. So discuss the mechanism of Wagner-Meer rearrangement. So this is also a 5 marks question, but it is asked in 2018. So that means 15, 16, 18, 19. So 4 years is asked about this particular question for 5 marks. So you can have a eye on this. Then Baeyer-Villiger oxidation of ketone. So that means ketone gets converted into ester by treating per acid. Then write a note on Beckmann rearrangement. It's a oxime is converted into substituted amide. This is also asked in 2016 and 2018. Then give the mechanism. Here is the indirect question. You can remember that. Give the mechanism of the conversion of ketone to ester. So ketone to ester means it's nothing but a Baeyer-Villiger oxidation. This is called Baeyer-Villiger oxidation. And then give the mechanism of conversion of oxime to amide. It's called Beckmann rearrangement. So both the things is the indirect question which was asked in 2017. So with this, what I will do, just I will repeat just I will repeat this rearrangement, quick revision on rearrangement. So for that, what I will do, I will go back. Okay, so this is about the rearrangement. See here what you need to remember, reactions which involve the structural changes in other parts of the molecule which do not participate directly in the reactions are called rearrangement, and all these such type of reactions has been grouped together and they named as rearrangement reaction or molecular rearrangement. So then in almost all rearrangement reaction there will be involvement of 1,2 shift. Okay, this 1,2 shift may be a alkyl group or a aryl group, and this migration may be a electron deficient carbon, or maybe a electron deficient oxygen, or maybe a electron deficient oxygen. So then what will happen, where you can find, you can found in the substitution reaction, or maybe in the elimination reaction. So then how more particularly, so this occurs by the protonation of alcohol. So protonation of alcohol, protonation of ether, protonation of alkene, protonation of alkyne. All these things, protonation, what will happen? There will be a creation of carbocation, and there will be a migration. Okay, that's about general information about rearrangement or molecular rearrangement. So now I will go to the next slide. So next slide is about Wagner Merwin rearrangement. So it is asked, you can observe that 1916, 2015. The question is in a different form, that's all. So here by taking a suitable example, but here discuss the mechanism. So that is what the difference. So then what will happen here? So there will be a movement of, so I think you know that SN1 reaction. What is happening in SN1 reaction? Living group will going out. Once the living group is going, there will be a formation of carbocation. So usually in the SN1 reaction, the carbocation formed one the primary carbon, primary carbocation. If there is a possibility of movement of migration of alkyl or aryl group from the adjacent carbon to the carbocation, if that leads to a tertiary carbocation, so such migrations are called Wagner-Merwin rearrangement. So what is happening here? A more stable tertiary carbocation is formed during the SN1 reaction, and these reactions involve the migration of 1,2 shift. Okay, so such type of reactions are called Wagner-Merwin rearrangement, and these reactions occurs during the SN1 reaction. So let's go into the examples. So here I am taking, so this is called a neopentyl bromide. So SN1 reaction means this bromine will go out. When this bromine is going out, there will be a formation of carbocation like this. So this carbocation is a primary carbocation. Adjacent methyl group can move from here to here. Why it is moving? It's moving because of the formation of tertiary carbocation. Once there is a tertiary carbocation is formed here, then what will happen? So this is stable compared to the this one. So that is the reason. So there will be a loss of proton. This proton will go out, forming a double bond alkene. So what it means? It means that when a neopentyl bromide is treated with when undergoes SN1 reaction, so usually one as per SN1 one can expect this product, but this product is not formed, and this product's alkene is formed. So definitely this is formed through rearrangement, and this rearrangement is called Wagner-Merwin rearrangement. Okay, that's what you can write this reaction, and you can write this mechanism. Okay, then so here I'm okay, what is the difference here? Okay, I will take this. Right. So here also secondary. So when this SN1 when this substitute, when this group is undergoes a, when this compound is undergoes a nucleophilic substitution reaction, so this bromide will go out. So when this bromide is going out, there will be a positive charge formation, and this methyl group is migrated over, forming a carbocation that was attacked by alcohol or water, giving rise to alcohol like this. This is the mechanism. Okay. And in the case, suppose if there is a phenyl group is here, the formed one is the more stable carbocation, and here only the SN1 reaction, but not the Wagner-Merwin rearrangement. That you need to remember. So this is the product during the petroleum cracking. So protonation of petroleum cracking product giving rise to what is called as a Wagner-Merwin rearranged product. This is about the Wagner-Merwin rearrangement and the allylic rearrangement. So allylic rearrangement means so what will happen? Solvolysis. The treatment of ethanol is called solvolysis. So solvolysis of 3-chlorobutene. Otherwise, here one more product. So this substituent, this solvolysis also gives the same product. So what it means? It means that uh, so it means that definitely these products are formed through rearrangement, and that rearrangement is called allylic rearrangement. This is a reaction you can write. If you are looking into the mechanism, this is one. So what will happen when it is treated with ethanol? So there will be a form, this chlorine will go out forming a cation like this. Of course, this can picks up a proton, and the cation one is stabilized. How it is stabilized? Means uh, okay, right. And these two are the cation, means this is the primary carbocation and this is the secondary carbocation. So because of this cation, ethanol can attack either this carbon or that carbon. So more particularly, it can attack, this is the stable one, this is the less stable one, and it is also forming a two product. This is about the allylic rearrangement reaction. Suppose if there is a ethoxide concentration is more, then that time what will happen? It's only a nucleophilic substitution reaction, that is called SN2 reaction. So SN2 reaction means what is that? It will attack this carbon, this bonded pair can come over here, this will go out. So it's called SN2 reaction. SN1 reaction means initially there will be a formation of carbocation, whereas the SN2 reaction, so there will be a simultaneous bond breaking and bond forming occurs. So in SN2 reaction, this is about the allylic rearrangement. So pinacol pinacalone rearrangement means vicinal diols. Vicinal diols, when it is treated within proton, so what will happen? This is protonated and it will go. Once there is hydroxide will go out as a water, there will be a formation of positive charge, and this bond pair is methyl group is migrated to here, and the bond between the oxygen nitrogen breaks and forming a ketone here. That is how the pinacalone is formed. So overall, pinacol pinacalone rearrangement occurs in the case of vicinal diol containing compounds in presence of H plus. So then I will go to the Hoffman reaction. So Hoffman reaction means amide. This is amide. Amide, when it is treated with sodium hydroxide in presence of bromine, it gives amine with one carbon less. So that is the important thing you need to remember. Then what will happen? These are the mechanism. So first step is the formation of hypobromide. This is the hypobromide. So this hypobromide can obstruct a proton, forming a sodium hydroxide and the N-bromo compound. So then this formed NaOH can obstruct this proton, forming a nitrogen anion. So here there will be a migration. That means this anion can come over here. Here this R group is migrated from carbon to nitrogen. Why it is migrating? Because electron deficient nitrogen. This is an example of migration of alkyl or aryl group to the electron deficient nitrogen. So then the obtained one is ketene. Ketene is when it is treated with water, it gives carbamic acid. So then carbamic acid on heating undergoes decarboxylation forming a product. So this is about the Hoffman reaction. Overall, Hoffman reaction means you need to remember that it is nothing but a conversion of amide into amine with the loss of one carbon atom. So then what will happen? It's a Beckmann rearrangement. So Beckmann rearrangement, give the mechanism of Beckmann rearrangement, 3 marks question in 2008. Write a note on Beckmann rearrangement, 4 marks question in 2003, 2011, 2012, 2013. It's also one more question is framed. Give the mechanism of conversion of oxime to amide. It's again 3 marks question. So here what is happening? This kind of C double bond NOH kind of functional group containing compounds are called oxime. Okay. So this oxime, when it is treated with proton, the proton source may be a phosphorus, phosphorus pentachloride or thionyl chloride or phosphorus oxychloride. So what will happen? There will be a substituted amide is obtained. How the substituted amide is obtained? So because there will be a migration. So migration of one of the phenyl group uh, from this carbon to nitrogen. So the benzanylide. Then one can frame a question like this: how do you convert benzophenone oxime to benzanylide? So that time also it belongs to the Beckmann rearrangement. Then let's. This is about the general mechanism. Instead of R and R dash, it can be a alkyl group or a aryl group. So this is an oxime. So protonation of means lone pair present on the oxygen can obstruct this proton, forming a hydronium ion. This hydronium is ion is unstable. It will go along with this bonded pair. There is a formation of nitrogen means nitronium ion. Nitronium ions are unstable. Then this bonded pair is means this alkyl group is moved from this carbon to this nitrogen. This is also called as 1,2 shift, forming a carbocation, and this carbocation attacked by water moiety and giving rise to substituted uh, amide. So these are the so here it's in terms of representation with the structures, but here in terms of words, treatment of oxime with the acid generate the leaving group on nitrogen atom. So loss of leaving group generate a electron deficient group. Migration of group of adjacent carbon to the electron deficient nitrogen. The attack of water molecule on the carbocation followed by loss of proton giving rise to amide. This is about the Beckmann rearrangement. Then Bayer-Villiger oxidation. So these are the two questions asked in 2008 and 2012, 2018 also, 2016 also, and of course 2017 also. So overall here what is happening? There will be a conversion of ketone into a ester in presence of per acid. You can observe that this is called carboxylic acid. If we are adding one more